here. I think it's working.
I determine winner is the worst.
And yeah, we're back to Linux because it worked so well in Windows last time. Let's see, 46A.
Will we be using Chapter 9 or Final?
Yes, and that's why I want to get a head start on it. I know, it's in the syllabus, for better or worse.
Final's just more problems, right?
No, the final is 7 or 8 problems because you have so much more time. Yes, it is. The final is comprehensive. And it's going to be either 7 or 8 problems.
So it's like the midterm for time two.
It's like the first and the second midterm combined.
Nice.
Yes, it's a lot of problems. We're trying to make them a bit shorter, but we're supposed to be covering a whole bunch of different things from the learning outcomes, and so a good strategy on the final is surely going to be to read through the whole thing and do what you think are the easy problems first. Look for the ones where you trace some code. I mean, that's something that's got to be easy. There's going to be one problem with graphics, and in all likelihood, just like in the last 2 exams, we're giving you the viewer and we're giving you the component thing, and just need to be prepared to put that quickly into BlueJ and just get going with the essential part of the graphics, so that you don't waste any time with that. There were some complaints that it was tedious to copy and paste things out of the PDF. So this time we're going to give you a zip file with all of the basic code as well. So if you prefer, you can use that. You can do the stuff with the dots. So you can either take it out of the PDF or out of the zip file, what you prefer. You just need to make sure that you can do that quickly out of the zip file. All right. So the next 2 chapters, we're going to be going into them in sections 1 through 3. So we're going to do chapter 9, 1 through 3, and then chapter 10, 1 through 3. And then we're going to be revisiting that whole thing again in 46B. But the syllabus for 46A says that you should have some basic competence in these things. And what are you going to do? That's what the syllabus says. For borrowers, we're starting off with this concept called interfaces. So let me just give you the motivation, because it really is pretty abstract, and it's not something that I think you would have ever seen before. So if you look at, this is the program that we had in Chapter 6, and in Chapter 6 we had a program that read in floating point numbers, and it looked through all of the numbers in the input, and at the end it told you what is the sum of all of the numbers that was put in, and what is the largest. And so in this example here, this has been modified to work with bank accounts. So over here, this is not very well. So over here, we now have bank accounts instead of double. And so they changed all the double to bank account, or I did, because I wrote this. And so there's now a bank account maximum, a bank account that's being added in, and a bank account to get the one with the largest balance. And now over here where we compare things, we have to compare whether the new bank account that gets put in is bigger than the bank account we've seen before, and that's done here by calling get balance on the bank account. So, and that's what you have to do, because a bank account, you can't directly compare. You can't do maximum is less than X, because maximum is a bank account, and you don't have a less than operation on bank accounts. You have to say, go in there and find the balance. It's kind of the same thing as finding the candidate with the most votes. You have to go through the candidates, and you have to say, what is get votes? So you have to say, the largest .get votes is less than current .get votes, and if so, you have to change your mind who was the largest one. who was the winner. And so we have to call this method. Now, that's of course not a big problem, because you can copy and paste this code, change all the doubles to bank accounts, and glue on that .get balance there. Now, let's say you want to now compute the maximum of a bunch of objects of some other type. So here I do it for coins. And it does the same thing. It goes through here. Sorry. It shows up different on my screen than on yours. Try if I can compensate. Nope. Oh, there's this little pin, and it draws on the screen.
Can I draw?
No, you had to. Someone paid an extra $500 for the technology here, and it's just that where I draw shows up in a different spot. So I'm trying to finesse this. All right. So here I change every double to coin, and here again I change the double to coin. Here I change the double to coin. And now I have to make one other change. Where previously it said get balance, a coin has a method called get value that changes to get value. So I copy and paste, I change all the bank accounts, all the doubles to coins, and I glue in the get value. Now, in fact, you could do the same thing with those candidates. If you want to find the maximum of the candidates, you could just copy and paste this code and change all the doubles to candidate and glue in the get votes. And now at some point you say, that's not a good way of dealing with solving the same problem 3 times. Copying and pasting and making changes like that, that's good enough for a freshman, but it's not something that you'd want to do as a professional. There's got to be a better way. And so the question is, how can you reuse this basic code that figures out how do you compute the maximum? A code that we're writing 20 times. How can you make it so that you only write that code once? So that's the whole motivation that underlies what we're trying to do. How can you not rewrite the code over and over again when the code does something completely and utterly basic? And so one way of doing that is to use these interfaces. So let me show you that how that works. So the difficulty is that all of these different classes, the bank account, the coin, and the candidate, they used a different way of finding out how big the thing is, meaning how much money is in the bank account, how many votes did the candidate get, what's the value of the coin. If they could just all agree, life would always be more wonderful if we could just all agree. Don't you agree? If we could all agree on that the method that's used to find out how big something is called get measure. I don't want to call it get size, because I thought that was kind of maybe not neutral enough. So, come on, Penny. Okay, this is... You can see the cursor here moving around. Can you? Yeah. So, this get measure thing here, if we could all agree on calling it get measure, then the rest of the code would be nice. So why is it highlighting everything now? Isn't technology wonderful? I'm sorry, it wants to highlight it. I have, in fact, no idea why. Okay, now we kill it. All right. Let's see if I can now paint again. Yes. So here we have get measure, and now you see the exact same lines of code that you've seen a million times to compute the maximum, except here it's done with get measure. So this would work for anything that has a get measure method. And if we could just rig things so that bank accounts and stuff have a get measure method, then we could feed them all into the same algorithm. And so the way this works in Java is we can define a type, and that's done down here. And that says, this is a type that describes things that are measurable. And so you see it's called measurable. It has a get measure method. But it's not called a class, it's called an interface. Note here where it says interface. I'm not winning this one. It's called an interface. And an interface is something it's kind of a promise that we're going to be implementing this method. So it's a somewhat abstract thing. So the long-term interface says, I I solemnly promise to give you a get measure method. So a class has to say, I want to be a part of this interface thing. We'll see that in a minute. Notice that the get measure method over here is not implemented. So the interface only gives the promise that someone is going to implement it. The classes later have to actually provide the implementation, and every class is going to be doing it in a different way. So let's see how a class promises that it'll be a part of it. We'll see that here. Then I'll go back to how to use it. So over here you see where it says implements measurable. That's not where the bank account says, I want to be measurable. And by doing that, if the bank account has an obligation, it has to implement the get measure method. And here, of course, that's pretty trivial. If you wanted the candidate class to be measurable, so that you wouldn't have to write the code for maximum and minimum yourself, then your candidate would have to implement measurable, and it would also have to implement get measure. So let's just do this here. Class candidate implements measurable. Then you have all of the other things that the candidate has to do, which I'm omitting here, and then I would also have to say public double get measure return. Okay, what should it return for its measure? So my question is, the candidate now implements measurable, and it needs to then provide a get measure method. And what should it return? What's the measure of a candidate in our program? Do we care about? We just care about the votes, right? We don't want to find the tallest candidate. In that case, they would have to return the height. But we want to find the one with the most votes. So that's what it would be. So if we did that extra step, then we could reuse the max and the min, which actually would be kind of a nifty thing to be able to do, because then you wouldn't have to write those extra lines of code. All right. So now back to the implementation. So here's how the data set now would work. And this data set is a little bit primitive. You have to add the things one at a time. You know, it would be. I should really change this example so that it can compute the maximum and minimum of a whole collection. But there's a technical reason I didn't do that. All right. So we're adding them all, and then here when we find who was the biggest one, then we call the get measure thing. So there's two sides of the coin. There's the supplier of the service. The supplier of the service says, I'm going to work on anything that is measurable. Oh, it's so beastly today. Alright, I'm just going to point here. Anything that's measurable, and then they use the get measure thing in here, and they write their service in the usual way. In this case, the service to compute the maximum. And the user of the service, that would the bank account, says, okay, I want to partake in this. I promise to implement this interface. I provide this method. That's the end of the story. So it's actually not a terrifically complicated idea. It says that the supplier of some service wants to be as general as possible, and then they need to come up with this interface that says what's kind of the minimum requirement that one needs to contribute to play. If you want to compute maximum, minimum, sum, those kinds of things, then it has to be, one has to find out how big is the thing, how do I compare it? And so measurable does that. So why do people find it confusing? I think when one sees this thing for the first time, down here where it says interface measurable, and it has a method that does absolutely nothing, it's easy to say, well, what's the point? Why would you supply a method that has no implementation? And the reason you have to do that is when you write the code, you see the code up here, one has to know what to call. You have to call some method, so it has to have a particular name. Otherwise, you can't write the call. So I want to compare these things, and sometimes it's the size, sometimes it's the balance, but it has to have a common name. And also, then when you put the code inside a method here, where I add something. So I add an object to this data set. An object of what type? Well, it might be a bank account. It might be a candidate. It might be a coin. And you have to give it some name. You can't say, give me anything at all, because there's actually a more general class, let's see if I can, called object. I have no idea how this is not working anyway. Let me try something. Oh, yeah, so there's a class called object, but I can't use the word object here because if I tried that, over here it would choke and it would say object has no get measure. So there's a class object that has like no methods at all. It has a couple of methods, but none that are interesting. And over here, when you say x.getMeasure, then the compiler would say, well, it's an object. I have no idea what methods it has, so I'm going to assume it has none. And so when you try to call the getMeasure methods on it, I'm going to complain. That's how Java works. You can only call a method that the compiler knows exists. So that's the purpose of having this interface type, that way we're telling the compiler, hey, whatever this thing is, it has a getMeasure method. We don't know what it is, but it has one. So that's the basic idea. And I'll leave it here. We'll have a lab with that this afternoon so that you can get more familiar with it. What we're going to do right now is we're going to continue the lab with the packages. So I hope last time everyone got the Java compiler to work in the command shell, because we're going to need that for this lab. This is part D. If anyone has not gotten part D done, I'll make the rounds and see that I can fix your system for that. So in part E, we're going to be putting that to work. I hope you finished part D. If not, I will.
Should we do E?
Yes. So now you're going to have to do E. I will make the rounds and breathe on everyone's neck who didn't do D. This was lab 11, right?
Yeah.
And where the heck is that? Okay. All right. So in part E, you're going to have to do this package thing. If you remember, I talked about how to make packages last time, and I had this picture with the directory tree. Let me get that picture up again to jog everyone's memory. So remember this picture here, you're going to be in some base directory which is here. Now yours is not going to be called problem1, but what's it going to be called? What's the directory that you made last time?
CS11 lab.
CS11 lab, excellent. Okay. And so inside CS11 lab, you're now going to have to make a directory structure that matches the package that you asked to create. This is a package, com.horstman.big.java with 3 levels. I think you only have to make a package with 1 level. So you have to make that directory structure for, I don't remember. Can someone read up quickly what the package is called in lab E? One of you speed readers. I don't know, but someone's going to say package with some name.
edu.fjsu.
Oh, wait, edu?
Oh,
Oh, right, so I was cruel. Okay.
Cool.
That's it?
Yeah.
Okay, so So in this case, it's not com-horseman-big-java, but it's edu.sjsu.cs. So then you do have to make yourself 3 levels of directories to match the package. And then inside that, you put in your file, what was it, data set? Or data analyzer? Yeah. Whatever, data X. That's where you put in those Java files. And that's what you have to do. So let's see how that goes. And then when you compile, you're going to be using that Java C command, and it's important from where you issue that Java C command, and you do it from the base directory. All right, let's get going with that, and I'll make the rounds to see where it fails. I mean, it's a fussy process. People usually get it wrong the first time.